Hello everyone, dear JEE enthusiasts. Today is a very special journey. Unlike before, today we are going to go in a very exciting vehicle, and that's our warship. And you have to sail across rough seas, strong winds and very strong currents. And you have to reach the other side of the shore without getting drifted away too much. And in case you do not know how to sail, do not worry. Today Shreyas Sir is going to help you sail across rough seas, strong currents, beat any weather. All the JEE enthusiasts, JEE Enthuse is here for you. And remember one thing, without rain, nothing grows. Learn to embrace the storms of your life. Welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu, going live from the studio at Bangalore. How are you guys doing? Welcome, welcome, welcome. What an amazing day, what an amazing start, what a lovely quote. I mean, those of you who missed it, you should probably read it again. It's got a very beautiful meaning. I'll just keep it up on the board. Meanwhile, I'll just say hello to everyone. Hi Jumna, Deepak, Kiritok, Chini, Satish, Arman, Chini, Harshvardhan, Krishna. Welcome, welcome Abhishek, Ritesh, Uday. Hello Anu, hi Sanvi, hello Anthony, hello Varsha, hello Pranav, Anumeet, Senadita, Kavya, welcome. I have been reading all your lovely comments that you put up after every video and all the amazing messages that you have been sending me on my official Vedantu, Instagram account. Such lovely wishes, such lovely messages. People are saying that, they are started to love physics. They enjoy these sessions, they enjoy these codes, they enjoy these animations, they enjoy these visualizations. And I couldn't be more proud to get all such kind, heartfelt wishes from all of you. Look at the chat box, it's full of messages, it's full of, look at that chat box. It's so colorful, it's so nice to see all this. Yes, and so many of you are agreeing with that. Glad, I'm so glad. And let me tell you, today is a very special day because guys, JEE Enthuse has completed 5,000 subscribers. Yes, that's a big family, a big round of applause for every one of you. This couldn't have been possible without your love, without your support, without your hard work and dedication for this channel. It's hardly been a week. It's hardly been a week, guys, and we have got 5,000 subscribers for the JEE English channel of Vedantu. I'm so delighted. I'm so proud, I'm so happy, and all this effort goes to you because you are the ones who is making this possible. So please guys, like and share. I want to make this family really big. Let's not stop at 5,000. What do you say guys? Yes or no? Congratulations to every one of you undergraduate gamer. In fact, everyone. Yes, you have to. You have to make this family big. Let's make it big. Let's get everyone onboarded. Let's make sure all the people who wanted to learn in English, especially for JEE, are not deprived of this platform. Okay? Having said that, let me also show you the timetable. So this is the timetable for the next week. Let me tell you one thing, that on Tuesday, right? Instead of this, we are going to have integration because that was a very popular course on demand. And so it's actually going to be a difficult problem solving session. So in that, I'm planning to do only problems on integration and how to use them in kinematics. So keep that in mind. Tuesday is going to be integration related problems, and then we are going to do Newton's laws, a special lecture only for multiple pulleys and constraint motion, a special lecture only for pseudo forces, non-inertial frame, and just one lecture for frictional forces. So dedicated lectures just like we planned, because we don't want to hurry up things, and I'm planning to complete most of the major portions by November end. Yes, of 11th standard, and then we'll go to 12th. So all the 11th and 12th standard students, keep in mind, we are doing all the things necessary for cracking the immediate JEE Mains examination, and then we are going to level up to the next JEE Mains and the BITSAT and JEE Advanced. So do not worry. So I know you might be wondering, okay, that's on Tuesday, but what about Monday? What about Monday? Do you know what is on Monday? It's not a holiday, guys. It's not a holiday. Any guesses? Yes, Chini, I'll come for interactions. Don't worry. Yes, Deepak, I'll say hello to Pandu as well. Okay, so what is on Monday? Okay, so there is going to be a very special session. Yes, I cannot tell you the name right now, but it's going to be a very special session which will definitely help you crack JEE Mains examination. A very, very important session, so you cannot afford to miss it. And no, it's not a Menti quiz. Please spread the word for all the aspirants. It's going to be a very important session on Monday. All right, I'll tell you the exact details in a bit. You can keep yourself updated on the Telegram channel in case you have forgotten. This is the link. Oh, where did it go? Okay, the Telegram link is at the end, but also it's there in the description box. And also I'll be putting up all the details on my Instagram handle, Shreyas_Vedantu. So do not forget to follow it, and I'll be putting up all the details over there as well, and it will be there on Telegram as well. All right, so stay tuned. All three are going to come and give you a very special surprise on how to crack JEE Mains examination. All right, so stay tuned. Okay, great. So let's begin then. Welcome aboard, everyone. I can see a lot of people have joined in, and let's begin. And hopefully after today's lecture, you won't be the one saying this, because you're going to learn how to catch an umbrella in the rain, and you would know if rain falls this way, which direction should you hold the umbrella, even if you're walking, running, etc. All right, so you would know how to catch the umbrella, guys. All right, hopefully you will know it, and there are amazing problems on how to cross the river as well. Now, before going there, let's start with the basics. Like I have been always telling everyone that vector addition and subtraction are not separate topics. They are useful as tools for solving different problems. And I'm going to tell you a brief about vector addition because we're going to use it today. So pay close attention. Now, A and B are two vectors. I want to know what is the resultant, what's the combined effect of them. See, what is the meaning of addition? Addition means combining their effects. Now, if I say that I had 2 apples and then I had 3 apples, then 2 plus 3 is 5. That's the total, that's that sum. But if I apply 2 Newton force and then maybe I apply 3 Newton force in the opposite direction, then 2 Newton here and 3 Newton here is not going to give you 5 because direction matters. So understand, for vectors, it's not just about the magnitude, but it is also about the direction. So you need to take both things into account to find the resultant, their combined, their vector which is going to represent both their effects in a combined way. So what is the rule for that? It's very simple. So always take any one vector. Let's say I take vector A, which is like this, and then this is the head of that vector and this is the tail of that vector. So now slide the other vector without changing the direction and without elongating or compressing it. Slide it carefully and place the tail of vector B on the head of vector A. That's it. And there will be a missing side of the triangle. That missing side, guys, is basically A vector plus B vector. I can call it some vector C. So this is the resultant. This is itself, this A bar plus B bar, this is called as the resultant. Now this A and B can be displacement, it could be force, it could be momentum or velocity or acceleration. Any vector component or any vectors can be added via this particular method. This is geometrical method. And those of you are wondering, oh, why did I take A first? I could have taken B first. Yes, why not? So let's take B first. Let's take B first, guys. Okay, so this is vector B first, and I will place vector A exactly where B vector ends, right? So this is head, sorry, this is tail, this is head, this is the tail of the next vector, and I'll place it over here. Now, again, if you draw the missing side, exactly in the same order, very important to start from the tail and end it at the head. This will be B vector plus A vector. Believe me, this same thing is over here, because you can clearly visualize a very simple fact that this forms a parallelogram. Understand, this forms a parallelogram. This is actually A and this is B. So actually speaking, A plus B and B plus A are the same thing. So the order does not matter how you add it, the resultant effect always remains the same. Okay, so you go like this and then go like that, or you go like that and then you go like this, you will always land at the same place. Understand that? Okay, so that is vector addition geometrically. Okay, I hope you guys are understanding it. Yes, you can shift the vectors parallelly. So remember, the vector C, which is the addition of A bar plus B bar, is also B bar plus A bar. Remember that. So it is also B bar plus A bar, and this rule, there is a special name for it. In case you do not know it, this is called as the commutative property. This is called as the commutative property. But remember one thing, the length of this vector, length is not the same as this length plus this length. In fact, that's the rule of triangles, that the third side is always more than the sum of the other two sides. So obviously speaking, C should not be equal to A plus B, unless a very special situation occurs where A vector and B vector are in the same direction, then A plus B will be A plus B, magnitude wise. So understand that A plus B will not be equal to C generally, right? This is the rule of triangles, especially in this case, obviously it is not. So then you might be wondering, what is the value of C? Well, there is a formula, and let me tell you what it is. So if the angle between the vectors is theta, you might be wondering, why is this not taken as theta? Please remember, the angle between the vectors is always measured whenever you slide the vector such that they originate from the same point. So slide this vector B. For addition, no, don't slide it. Only for measuring the angle, slide it such that they originate from the same point. That is the angle between the vectors. Understand? So theta, guys, is nothing but angle between A vector and B vector. Understand that? So what is the answer for C? The answer for C is A square plus B square plus 2AB cos theta. So that's the formula. That's something which you should remember. Yes. Always measure angle when you join the vectors tail to tail. For adding, put head on the tail for adding, right? But for measuring angle, put the tails together. Remember this fact, okay? So this is a formula for vector addition, but you will hardly need it. Very rarely you will use it. Most of the times you will be using resolution or just geometrical methods like you are going to see. But nevertheless, I have given you the formula. Now, the next part is vector subtraction. This we are going to use it very often in today's lecture. And remember, subtraction is same as addition, but you have to take the negative of that. What do I mean by that? See, if I write there is a vector D which is A vector minus B vector. Okay, what this means is take A vector but add negative of B vector to it. That's all. So just take A vector as it is. So this is my A vector. Okay, now take B vector but the negative of that. So flip it. Just the arrow mark, the arrow which was pointing there will point here. So this would be minus B vector, and then guys, this one over here, remember this is A vector plus, just consider it like another vector. This vector is going to be the difference, or A vector minus B vector. So actually speaking, understand that vector subtraction is vector addition, nothing more, nothing less. Yes, don't worry Vijay, you are going to get flash extracts very soon, don't worry. Okay, now just concentrate. Now what if somebody asks, okay sir, then what is this vector E, which is B vector minus A vector? This is same as B vector plus negative of A vector. Okay, so negative of A vector. So what do you need to do? Take B vector as it is. Okay, so take B vector as it is. Take the A vector, negate it, just its opposite, So that is minus A vector, and that's it, guys. This one will be your E vector. So this will be your E vector. Look at that. I hope you also see that E vector will be opposite. I have not joined or drawn it to scale, but if I had drawn it to scale, E vector and D vector would be exactly opposite to each other. Yes. So D is the difference of A minus B, E is the difference between B minus A. These two vectors will be opposite of each other. Since I have not drawn it to scale, it's not exactly opposite, but it would have come exactly opposite, but same in magnitude had I drawn it properly. Okay, but I hope you get the point. Is that clear? Yes, E vector magnitude wise is same as D vector. Correct. Very good, very good. So let me give you the properties. So A vector minus B vector is not the same as B vector minus A vector. Remember that. It's not the same in magnitude. It's not the same in direction. Magnitude wise it is same. And just like before, if you just take the magnitudes and subtract it, you are not going to get the difference, because you have to also account for the direction. So understand that. So how do you find A minus B? Like I just told you, just subtract, just take the negative of B, and this one over here is your A vector minus B vector, which is also the difference. That's what it is. And if you want to know what is the formula for this, it's very simple, guys. It is A square plus B square minus 2AB cos theta, where theta is again the same thing. Same angle between A vector and B vector, not minus B. So it's the angle between A and B vector. Okay, I hope this is clear and very well understood. Amazing. Clear? Shall we go ahead? We are going to use this. Remember. Very good. I am reading your chats. Bahut hi badhiya. Amazing. Excellent, guys. That's the spirit. Very good. Uday, Krito, Jumna, Asmi, undergraduated, gamer, Gayatri, Chini, Anu. Very good. Very good, Sajid. Very good. Very good. Very good. Chalo. Let's go. Let's go. Okay, let's use this now. You might be wondering, how do I use vector addition and subtraction in motion, relative motion? How am I going to use it? Well, don't worry, I have problems for you. So imagine two people. Oh, and we have Pandu, of course. And we are interested in finding out, say for example, this guy is running with the speed of 5 kilometers per hour this way, and let's say this guy is running really fast, and maybe he's running with a speed of, maybe, I'm just guessing, maybe 10 kilometers per hour, and maybe that his angle is given and stuff like that, and I call this guy as number 1, and I call this guy who is moving faster as number 2. We'll just label him. And this is the observer. He's always observant, he's very jobless, and he's going to observe these two people running with the speed of 5 and with the speed of 10 in particular directions. Remember, both these observations are made with the same frame of reference. So what do we do? Here is the thing. So velocity of 1 with respect to 2. Suppose this guy wants to look at this guy. What will be the velocity of this guy with respect to this guy? That is the meaning of V12, in case you have forgotten. So V12 is velocity of 2 with respect to 1. What is that going to be? Well, that is simply put nothing but V1 minus V2. Oh, sorry, I think I put it in a wrong way. So sorry. So this is nothing but, yeah, this is velocity. Oh, sorry. If I want to observe 2, right? So I have to put differently, velocity of 2 with respect to 1. My bad. So this is V21 is velocity of this guy with respect to 1 is written like this. Velocity of 2 with respect to 1, and that will be V2 vector minus V1 vector. So like you can see, there is vector subtraction here. So let's use vector subtraction, guys. Yes, just think about it. So what is V2? V2 is 10. Okay, so let's use that. So V2 is 10 in this direction. So take a scale, and whatever angle they have given, just draw that. So that is nothing but your V2, which is having a magnitude of 10 in this direction, minus V1. So this is V1 subtracted. So this will be minus V1. Magnitude wise, it is still going to be 5. So that resultant, which will be over here, this one, guys, will be velocity of 2 with respect to 1. That's it. That's the answer. So you don't have to visualize anything. Just draw triangles. So for this guy, this person number 2 will appear to move in this dotted line direction, and this will be the length of the vector. You can use scale, measure it, and that would be the answer. Is that clear? I'm just showing you the method. I hope this is clear. Thank you, Sajid, so much. Thank you, Sajid. I'm so glad. I'm so glad. Amazing. So please remember, this formula has to be used when both these observations, yes, please keep this in mind, both these observations are made by the same observer. And who is that observer in this case? This guy is the observer. Remember that. Okay? Yes. If the angles are given, only then you will be able to find the magnitude, but I'm just telling you the method. Don't worry, we are going to come to problems also. First learn the method. Okay. But what if things are given with respect to different frames? Remember the transformation formula I had given you? So just use that, guys. It is not just applicable in 1D, but it is also applicable in 2D. Remember that. So, oh, just one second. Yeah. So imagine this guy's velocity, A's velocity is given with respect to C. So A's velocity is given with respect to C, and C's velocity is given with respect to B. And I want to know what is the velocity of A with respect to B, right? This is what I want to know. So what do you do in this case? Like you can see, the observing frames are very different. This is with respect to C, this is with respect to B, and this is also with respect to B. So what do you need to do? Very simple. I've told you this before, but I'm repeating this. Velocity of A with respect to C plus velocity of C with respect to B will be, look at the first and the last letters, A and B. C is common, so just put A first and then the last alphabet. The middle letter will just go off. Remember that. Okay, so this is C and this is B. So this is how you're going to do it. And what is this? This is vector addition. Look at that. And observe one thing very clearly. The frames are different. So whenever the observations are made with different frames, use vector addition. Whenever they are made with respect to the same observer, remember you have to use vector subtraction. Okay, I hope this is clear. Great. So this works for 2D, 3D, anything. Now, how do you apply them? Let's use this. So let's use this vector addition and subtraction. Yes, yeah, we will be doing that in special classes where we are going to do really difficult problems. Yes, we're going to do that. First, let's get to the first step. All right. Very good, Pavni. Very good, Chini, Devash. Bahut hi badhiya. Okay. Let's see, Sudhir. So imagine two projectiles thrown at different angles, different speeds. So this is 2D relative motion, right? So this kind of problems can come. Don't worry, okay? Similarly, a person riding in the rain. Rain is falling at an angle, the person is going at some speed. What is the relative velocity of the person with respect to the rain? Look at that. We are in the cycle frame. For us, the rain is coming like this. But actually, if you stand on the ground, maybe it is just falling straight. Who knows? So these kind of problems. So let's take up a problem to solve it. So two cars A and B are moving with the speed of 30 and 40 relative to the road as shown. What is the speed of A as measured by B? First, let's understand what has been asked. Only then we'll proceed ahead. Okay. So what has been asked? Velocity of A as measured from B. So that means VAB. This is the question. Okay. Now think, are the speeds 30 and 40 measured with respect to the same thing or different thing? Think about it. Is 30 and 40 measured with respect to the same thing? Think about it. Same. All raindrops, we are going to assume they have the same speed. They are going to be measured with respect to the same thing. Yes, very good. Now, if they are measured with respect to the same thing, will you use vector addition or subtraction? Try to recollect. When they are measured with respect to the same thing, you have to measure what will you do to find the relative speed? Vector subtraction or vector addition? Think about it. Yes, Gopal, this will be very useful. This is revision for 12th standard plus droppers. Yes, subtraction, correct. So when they are measured with respect to the same thing, always subtraction. Different things, those cars were there, A, B, C. Then you have to use addition, recollect. And those two people I had shown, one running here, one running there. Then that time, V12 is V1 minus V2. That was with respect to the same thing. So VAB is nothing but VA vector minus VB vector. Okay, so let's think about it. Where is VA? Well, VA is here, VB is down. Okay, so I need to use vector subtraction. So let me draw VA over here. So that is VA, guys. And how much is the magnitude of A? A's velocity is 30. So let me put 30 over here. VB is down. So this is VB. Okay, this is VB. And how much is the magnitude? Well, that is 40. But I cannot use VB. I have to use minus VB. So do not forget to negate it. So let's negate it and it will come somewhere over here. This is minus VB. Obviously, the magnitude will not change. Now, the resultant of both of them, VA and minus VB, will be over here. And this is VAB. Now, this is not that difficult to figure out what is the magnitude of VAB. Think about it. This is 90 degrees. This is 30. This is 40. So obviously, it will be 30 square by Pythagoras plus 40 square, which is nothing but 50 kilometers per hour. And what is the direction? Well, if somebody asks you what is the direction, well, it's simple. If I assume that this is east, this is north, this is west, and this is south, then I believe that this angle theta over here, this tan theta, will be 40 by 30, which is nothing but 4 by 3. Whose tan is 4 by 3? Think about it. It is 53 degrees. So theta is 53 degrees. So my final answer will be the velocity of car B with respect to A, guys. Okay. So minus VB. Yes, correct. So the velocity of car A with respect to B will be nothing but 50 kilometers per hour, right? In which direction? In that direction. That's it. It's not northeast. No. It's not northeast. Northeast is at 45 degrees. A lot of people think this any direction here is called northeast. No. Only when it is the angle bisector, it is called northeast. Same way, understand, northwest is not any angle, only when it is 45 degrees. So a lot of people get it wrong. Yes, so the better way of writing is 53 degrees from the east towards the north. 53 degrees with the east from the towards the north. I hope this is clear. Okay? I hope, Papi Reddy, this is clear. How to know northeast? Only if this angle comes out to be 45 degree. Malab, you would have got this also equal, then tan theta will be 1. Only then. Okay? Bhavya, just try to revisit this session afterwards. Don't worry, because a lot of people are going to then, face difficulty. Understand? Okay? Why didn't you take the positive vector? Which is that positive vector? Because VA should not be subtracted, guys. It's plus VA minus VB. So this vector, just forget it. Just forget it. We have to just take VA minus VB. That is VAB. This was just for reference to show you how we have negated it. That's all. Okay? I hope you understand. Yes, if you take VA and VB, that is going to give us something else. That's not what we want. We want VA minus VB. Please keep that in mind. Okay, so that settles this problem. Amazing. How to determine north of east, etc. So that's why you should use geometry. So when you draw those vectors properly here and there, you will see where it points. And that would be given in the problem. This is going towards east, that is going towards north. That's it. From the geometry only you will get the answer. Okay? Very good. So the direction of the relative velocity was 53 degrees in the northeast. Assuming this was north, assuming that is, this was north, this was east, else it would be given in the problem which is north and which is east. Alright, I hope this is clear. Okay, use your mind, guys, and please use pen and paper. Please use pen and paper, make notes. else you're going to find it difficult. You just cannot sit like a movie theater and attend these sessions. You have to learn it properly. Very good, Neha, Hemant, bahut hi badhiya. Very good, Papi Reddy, I'm glad. Let's solve Rain Man problem. Now, when a person is decently standing, okay, and the rain falls vertically down, how should he hold the umbrella so that he does not get wet? Okay, very good, Kirito, you're making notes. I've heard a lot of people, they have in fact messaged me saying that, sir, my entire notebook just got over attending your lectures just for 5-6 days. Thank you so much. Okay, I'm so glad. Now, when the rain falls vertically down, obviously the person should hold the umbrella straight like this so that he does not get wet. But if the rain falls at an angle, obviously he should hold the stick of the umbrella in this direction so that he does not get wet by the rain. This is very simple and this is very obvious. This is very obvious. But the problem happens when these gentlemen get into the mood, they put on some shorts and they start running in the rain because they're very enthused, just like our channel and just like you guys and just like we are, and they're running in that rain. And now we have to find what is the velocity of the rain with respect to the person so that he does not get wet so much. And what direction should he hold the stick and stuff like that. So what do we do in that case? Let's see. Now it's not so simple. It's not just, oh, you hold the umbrella in the direction of the rain. No, for him, how does the rain appear? That's what matters. Okay, so let's see one by one. Let's call this person number 2 and let's call this person number 1. I'm going to solve both the problems for you over here. Let's assume, okay, the velocity of the rain in the second case, right, is like this. This is the velocity of the rain in the second case, and this is the direction of velocity of the rain in the first case. Now, in both the cases, this is the velocity of the man, and this is also the velocity of the man. So if the rain falls like this, what should you do? And if the rain falls like this, what should you do? Very simple. All you need to think is, what equation should I make? And the equation that I'll make is the relative velocity of the rain with respect to me. All that matters is me, not the earth. I don't care about the earth now. I just have to think, oh, with what direction will I see the rain? And what is that notation? That notation is velocity of rain with respect to man, and that is VR vector minus VM vector. That is by definition. So this will be VR plus negative of VM. So every time you need to subtract velocity of man, not the rain. So let's do it. Let's do it for both the cases and see what do we get. So for the first case, VR1 is like this at an angle. So VR1 is at an angle. So this is VR1. VM is here. Do not forget to negate it. Do not forget to negate it. So this is the first situation I'm solving. So this is VM vector. So what is remaining? Look at what is remaining, guys. This is VR1, okay, or yeah, and VM is negated already in the first case. So the resultant will be here. This is the velocity of the rain with respect to the man in the first case. Think about it. So he will have to hold the umbrella exactly in that direction, which is not exactly here. It's somewhere like this. Understand? So he'll have to hold the umbrella parallel to this line, that black line that you see. So he has to hold the umbrella probably, if he does not want to get wet, something like this. It's not exactly parallel to the lines of the rain. Is that clear? Why man taken direction in left side? I have not taken man's direction as left side. I have taken negative velocity of the man. Please understand. Negative velocity of the man. Negative. Yes. Yes. So velocity of the rain is this way. As it is, the blue, that raindrops, velocity of man is there. Negate it. Okay. This is now vector addition. VR plus negative VM is VRM. So this is the direction in which I should hold the umbrella, and this is how I should hold it for me to get least wet. In the second case, right? In the second case, what I'll do? I am moving there, rain is falling down. So first draw velocity of the rain, guys. This is the velocity of the rain in the second case. Where am I moving? There. So negative of my velocity will be here. So this is minus Vm vector. Now, what do I need to do? Find the resultant of this and this. What is the resultant? It will be this one, right? It will be this one, guys. So that is velocity of the rain with respect to the man in the second case. So I should hold the umbrella stick in this direction. So that means this way. So my umbrella should be somewhat, think about it like this. For me, the rain will appear to come this way. Okay, I hope this is clear. Well, Sudhir, if the man's velocity was very large in this case, then believe me, this negative Vm vector will also be very large, and this vector will come like this. So you might have to hold the umbrella this way. It's very strange, no? That the rain is falling from behind, but you're traveling so fast that you're like Usain Bolt or something, that your Vm is so large, so negative Vm is so large, so this black vector comes like this. So you end up seeing the rain falling on your face. Okay? Think about it. Very interesting. Okay? Very good, very good. So, very important lecture. You might have to play this lecture even 2 or 3 times to understand this. But if you understand it in one go, you are excellent. Right? It is not so easy. I get it. But pay attention. Try to understand as much as you can. Next, let's solve some problems. So, essentially, for rain man problems, what do you need? You will be given velocity of the rain and, yes, Dushyant, pay attention. You'll be given velocity of the rain, velocity of the man. What will you do? Always negate velocity of the man. And that's it. So, VR minus Vm will be VRM. This is the governing equation which you need. Chalo, write it down in your notes. VRM is VR minus Vm. That's what you're going to need, guys. That's what you're going to need. Okay, so it's vector subtraction that we are using. And that's why I taught you vector subtraction at the beginning of the session today. Come on, guys. Very good, Anu. Very good, Sudurti. Okay, drawn and written. Amazing. So let's solve this problem. Rain falls with a speed of 5. We are going to solve 2 amazing problems, okay? 5 meters per second at an angle of 37 with the vertical, okay? And the person is moving as shown with a speed of 3 meters per second. What angle should he hold the umbrella? Come on, I'm really interested to solve this problem. How should he hold the umbrella, guys? Okay, so let's see. Okay, so first, let's write everything that we know. So, he is moving with a speed of 3. So, I'll show the person's speed. Vm is 3 meters per second. And the rain's velocity is also known to me. So, the velocity of the rain is how much? It is 5 meters per second, and this angle is given to be 37 degrees. Okay, now let's think. What do I need? I need VRM, right? So let's write down our starting formula, because to hold the umbrella I need to see it from the man's perspective, and by definition VRM is VR minus Vm. So let's draw it. It's not that difficult. VR is this way. Okay. So VR is going to be this way. And how much is it? It is 5. And with the vertical, just 1 second. With the vertical, it is making 37 degrees. Now, because it is given 37 degrees and this is 5, I feel that we can split it. That will be better. So this VR actually downwards is some magnitude and this way is some magnitude. How much is it? This is 5, this is 37. So this is smaller angle, so smaller side, and larger angle 53 will have 4. Remember this triangle 3, 4, 5? I have been telling you about this many times. So 3, 4, 5. 90, 37, 53 degrees triangle. This is a standard triangle which you should know. Now this is very important. Okay, what I have done essentially is I have split VR vector into 2 smaller components. For downwards and 3 towards the right side. Why did I do it? You'll understand it shortly now. Now next, what do I need to do? Minus Vm. Remember, Vm will be here, but I don't need Vm. What do I need? I need minus Vm. So let's just get rid of Vm and let's just put minus Vm over here. This is minus Vm. And how much is the value of minus Vm, guys? 3. And what was the length of this side? That was also 3. Oh, this is so interesting. This is so interesting. Think about it. Vr is here, minus Vm is here. Guess what? Where did the head of this vector land? Exactly below the tail of the Vr vector. Exactly over here. Luckily for us, both the magnitudes were same. Yes, I'll just repeat what happened. Vr vector was like this. Okay? How much was the magnitude? 5. Vm vector was there, right? So minus Vm vector was here. But the best part is, because the length was exactly 3, it has not missed it. It has exactly fallen onto this point. Because we know the height is 4 and the base is 3. For a 37, 53, 90 triangle having magnitudes 5, 4, 3. So that means, where is VRM? VRM, guys, is this one. Right? This is VRM. This is VRM. So what is this angle? What is this angle? 90 degree? What is this angle? 90 degree. Got it? Got it? Very good, Yog. Very good. Sudhanshu, very good. Suzuti, very good. So for him, how will the rain appear to come? How will the rain appear to come? Vertically down. Yes, you didn't need any other knowledge from whatever you have learned from today's lecture. So he will, guess what? Hold the umbrella like this. Interesting. The rain is coming like this. He is walking like this, but he will hold the umbrella straight. Because for him, the rain will be falling down like this. Yes, Lone, please, please, come on. Try and understand this. Yes, very good. So, whatever doubt you have, undergraduate gamer and Lone, do not forget that you can always comment below the video. Later on, I can solve you, or you can also send a doubt if you have to our doubt team on the Vedantu app itself. Yes. Okay. Very good. Very good. So don't worry, undergraduate gamer. Once you see many problems like this, you will understand it. Amazing. Yes, somebody is saying we should give him a raincoat so our problem will be solved. Yeah, maybe. But he doesn't have a raincoat. So the angle, by the way, is 0 degree. It's not 90 because the question was with the vertical. So with the vertical, he'll make 0 degree. 90 degree will make the umbrella look like this. Okay, so keep that in mind. So next, the rain falls with a speed of 5, but this time the angle is 37, same thing. And the person is moving in the reverse direction. So now, what direction should he hold the umbrella? So let's see this again. It's not that difficult. Let's see. The velocity of the man is how much? 7. What is the velocity of the rain? 5. Okay, it's 5, guys. And it is making again an angle of 37 degrees. Again the same thing. Velocity of rain with respect to man is Vr minus Vm vector. Okay, so Vr vector is over here. Okay, the magnitude is 5 and the angle that it makes is 37 degrees. But Vm is here, so when I have to write minus Vm, do not forget this will be minus Vm. And the magnitude is 7. This is the strange part. Understand that. So minus Vm is that side. Keep that in mind. So what do we do? Think about it. Okay. So now Vr minus Vm will be somewhere like this. This will be your VRM vector. This will be your VRM vector, guys. I hope this is clear. Now, if you are wondering, what is the angle with which you should hold the umbrella, as in this angle? This angle. If you are interested in this angle theta, what do we need to do? Okay, simple. Just complete the geometry like this. And now think, in this small triangle, if this side, this black side, right? If it is 5, this is 37, this is 90, what will be this side, guys? This side will be 3. and what will be this side? Think about it. This side will be 4, right? This is 3, this is 4. So how much is this? How much is this? Think about it. This much will be 10, right? So what will be this angle? Think about it. Tan theta in that big triangle. This is how much? Opposite side, 10. And what is this side? Think about it. 4. So that is nothing but 5 by 2, guys. Therefore, theta is just tan inverse of 5 by 2. That's what you will leave the answer at. Okay, that's how you will do it. Amazing problem. VR was here, velocity of the man was here, so we negated the man's velocity. It came out there. By triangle law, I have found out the resultant, VR minus Vm. I have drawn VRM, but to find out the angle which the rain makes, I have constructed a big triangle, and in this small triangle, since this was 5, this was 37, this is 3, this is 4, now if this is 3, this is 7, this is 10. So for that big triangle, the opposite side to theta is 10, the adjacent side is 4, so 10 by 4 is 5 by 2. So that's the answer. So he is going to hold the umbrella at a much steeper angle. That's what it's going to be. Chini, you should know the values of sine 37, cos 37. You should know that 3, 4, 5 triangle. That's a standard triangle, very useful triangle. Okay? Yes. Once you know this trick, that's it, guys. It's easy peasy lemon squeezy. You have to make this problem easy peasy lemon squeezy. Yes, tricky one, yeah, I agree at times, but if you know the trick, it's easy peasy lemon squeezy. Okay, so the answer was not 45, guys. It was tan inverse of 5 by 2. Now let's look at river boat problem. River boat problem. Okay. So and even river swimmer problem. All these problems are identical. So let's solve a simple problem first, and then let's go to the more difficult one. So imagine a boat can travel with a speed of 13 in still water. If the speed of the stream is 4 kilometers per hour, what is the time taken by the boat to go 63 kilometers? To go 63 kilometers upstream. What will you do? What will you do? Come on. Think about it. Upstream. What does it mean? You are going in the direction of the flow or against the direction of the flow? You will be going against the direction of the flow. Yes, correct. So imagine if the river is moving with a speed of how much? 4 kilometer per hour. You are traveling against it with how much speed? 13 kilometer per hour. So your actual speed, how much will it be? Your actual speed will be 9 kilometer per hour. You are going 13, the river is pushing you back 4. So you are effectively going only 9. Yes. So how much distance you have to travel? 63 kilometers. You have to travel 63 kilometers this way, and with what speed? 9 kilometers per hour. So how much time are you going to take? Time is distance divided by speed, which is 9. So that's it. The answer will be 7 hours. Very good. Very good. Now these problems were easy. Easy peasy lemon squeezy. Till your 9th and 10th grade. You just had upstream and downstream. But now let's add one dimension because you're studying 2D, guys, with me. And that's what JEE will ask you. They'll ask you 2D related problems, not just upstream and downstream. What if you're going perpendicular to the flow? Yes, that's what we're going to do. So let's see what happens when we go perpendicular. So there are some terms which you should know, and I'll tell you what those terms are. So imagine you're looking at it from the top. This is the river. This is bank 1. This is bank 2. Okay, so this is the bank of the river. This is the river itself, which is moving like this. You will have some speed with respect to the water. That speed I'm going to call it as U. The river water will have some velocity. Your velocities and the river velocities effects will be compounded, will be added, and you will get a resultant velocity. I'll tell you how. Look at this. If I tell you velocity of the swimmer or the boat, right, with respect to the water has to be added to the velocity of the water with respect to the ground, that will be equal to, remember, when two things are added, relative velocity. This is the term in between. This is the first letter. This is the last letter. So it will be V, S, G, right? Now this is very confusing to remember. So I have developed a very simple notation. What is VSW? VSW is nothing but U. U is the velocity of the swimmer with respect to water. What is VWG? VWG is the water's velocity or the river's velocity. So it will be called as W, just W. W is the water's velocity. So your resultant velocity will be just V. So if there is an observer standing on the ground, so let's say there is a Pandu standing here, right, and he's making some observations. For this Pandu out here, he will see this velocity, velocity of the swimmer with respect to the ground. Understand, this is what he is going to see. This is with respect to the ground frame, remember that. Okay, I hope this is clear. Yes, I hope this is clear. Is this clear, guys? Let me know. So remember one thing, U is the swimmer's velocity with respect to water. W is the water's velocity. Normally, river is flowing with this much speed. And V is the net velocity of the swimmer as he will appear. Amazing. Now let me show you an amazing simulation by which you will never forget things. You will never forget things. Okay. Now this was the equation that we just came up with. Remember this, please. This should be in your notes. This should be in your notes. Keep writing it. V is U plus W. And write down what each term means. Write down what each term means. Okay. So now we have to find out a lot of things like time taken to cross, drift encountered, crossing the river using shortest time, and yes, and crossing without drift. So many cases are there. It's very easy, and we're going to solve it by taking some problems. So there are a lot of situations. How do I so what is the time taken to cross? What is the drift that I get? What is the drift? Drift means how much do I shift because the river is going to carry me, and how do I cross in the shortest time? How quickly can I cross it? And how can I cross without encountering any drift? These are the 4 things which you should know, and let me show you a simulation by which you'll understand it and never forget in your life. Okay, so let's begin. I hope everybody can see this. Okay, I hope everybody can see this. Yeah, everybody can see this simulation. I'm going to be out of the frame for a bit. Yeah, I'm going to be out of the frame for a bit, but you have to pay close attention to my voice, whatever I am saying. So pay close attention. This is the width of the river. This is the boat or the swimmer, doesn't matter. Here I'm going to adjust the boat speed. Okay, I'm going to adjust the boat speed. And where did it go? Okay, there is start and reset as well. Okay, and I can select it to be whatever I want it to be. Okay, so let's keep it now at 5, let's say, or something. Okay, whatever, 4.9, or I can even change it. It's not that difficult. Let's keep it at 5, and let's see how does the boat go. The boat goes straight like this. As usual, it has to go and it will reach point B. Look at the distance between the banks of the river. I think it was given. Yes, it is 1000. So it has taken 200 seconds because it has gone with the speed of 5. I can change the speed, make it little bit faster. Maybe I can make it 10 and also see how does it actually move. And this is how it goes. Because the speed is 10, I think it will take 100 seconds to cross the river. Is that correct? Yeah. So guys, please use landscape mode and turn off the chat, or just put the chat aside so that you can see it very clearly. I would advise you to please use either a tablet or a laptop to see this clearly. And anyways, you can find this simulation on GeoGebra. Just I'll mention the link later on Telegram or something else. Okay, do not worry. On Telegram or something, I'll give you the link, but you can zoom on to it later on. Just observe. I cannot zoom onto it more because then things will start going out of the frame. That's the problem, guys, understand. Okay, now what we are going to do is, we are going to increase the river velocity. Think and tell me, if I increase the river velocity, will he reach the other side faster, slower, or in the same time? Come on. Will he reach the other side faster, slower, or in the same time? Think about it. If I change the river velocity, I have not changed it yet. I'll tell the website later on. Slower, think again, it will not be affected. This is what nobody tells you. That's why you are here. And I am here to tell you this, that it will not be affected. Don't believe me? Try it out. I'll make the river velocity something. Yes, the moment I added some river velocity, the blue arrow mark, look at the resultant, it will go here. If I reduce the river velocity, it will be less. So let's increase the river velocity and let's see, guys. Keep a watch on this time. Keep a watch on this time and see what happens. See what happens. It's magic. Or no? 100 seconds. Isn't it cool? So cool. 100 seconds. Even if I make this 0 with no river velocity, it takes 100 seconds. Amazing. It should not matter. How should it matter? Your velocity in this direction never changed. Let the river velocity be anything. How does it matter? It will just come here, but your your velocity in this direction is still the same. How does it matter? How does it matter? Think about it. Isn't it? So think and tell me, if you want to cross the river in the shortest time, what will you do? What will you do? Will you steer the boat? Okay, forget now river velocity doesn't even matter. We just proved river velocity doesn't matter. So how will you steer the boat? Will you steer it that way? Will you steer it 90 or will you steer it like this? Well, don't believe me? Okay, let's steer the boat like this and see how much time it takes. See that time. Just see that time. Just see. See how much time it takes. Bloody 122 seconds. Let's try this at some other angle. Try this. It has already crossed 100 and 117.92 seconds. More. Okay, so the only possibility is if I make it 90 degrees. Okay, let's keep it 90. And then it takes the smallest time. River velocity has no role to play in this. Understand that. Because river will just pull it that way. How is it helping it this way? Yes, you might go like this. The distance might be more, but you have to just cross. You have to reach anywhere. I am not asking you to reach here. I'm just saying reach anywhere on this line. So when you have to reach anywhere on this line, what matters is this distance and what is your speed perpendicular to the banks. This velocity will never matter. So if I put any other angle, let's say like this, okay, just see what the time was to cross the river. Okay, it will be more obviously than 100. Okay, somewhere around 122. Now let's add some river velocity. So because of the river, it will drift more. And let's reset and see what is the time. Just remember it was 122 before. It was just 122 sometime back. It will be still the same. Look at that. Look at that. It didn't change. I'll change the river velocity even more. It will still be the same. Don't be surprised. Yes, it is the same. It is the same. It is the same. Amazing. Yeah. So if river speed is more and boat also is tilted here, obviously, guys, it's going to get drifted. So what is the drift? Drift is from this point to this point. This is called as the drift. So guys, think and tell me, what will the drift depend upon? Drift will depend upon not just the river velocity, but it will also depend on how much is my boat velocity, and it will also depend on the angle at which I steer the boat. So the angle, the river velocity and the boat velocity will all matter. Understand that. Because when I change the boat velocity, the triangle, velocity triangle will change. Understand that. Is that clear? Now, to cross the river in the shortest time, what will I do? Always try to swim at 90 degrees. So then I'll cross the river in the shortest time. But let's say, because when I cross the river at the shortest time, I get drifted here, right? And the drift is being only caused by which velocity? The river velocity, this river velocity. And let's try this out. Let's put some value and see what happens. Okay, look at that. How much is the river velocity? 5, correct? River velocity is 5. How much time did I take to cross the river? Think about it. Oh, wait, I'll just put some decent values so that we find it a little bit easy to calculate. Okay, let's do this. So if I put 10, it takes 100 seconds to cross the river, right? It takes 100 seconds. So I spent 100 seconds inside the river, and in this 100 seconds, the river carried me this way. The river has carried me this way with what speed? 5 meters per second. So 5 meters per second into 100, how much will this be? How much will this be, guys? Come on, think and tell me. 5 meters per second, and I spent 100 seconds. How much will this be? Yes, 500 meters. So I will drift by half a kilometer over here. So that's my drift. The river width is quite large. It was 1 kilometer. So I would have drifted by half a kilometer because I spent a lot of time. And if I increase the boat speed to 20, how much time will I take? Think about it. How much time will I take? Quickly, come on, tell me. How much time will I take to cross the river? How much time? Width is 1 kilometer or 1000 meters. How much time will I take? Come on, think and tell me. Very good. Some of you have got it. Yes, 50 seconds, guys. Because think about it. No, don't add 20 plus 5. River velocity has got nothing to do with it. In this direction, the speed is 20. This width is 1000. 1000 divided by boat velocity. 1000 divided by 20. How much is it? 50. And this drift, how much will this drift be? Think about it. I have spent 50 seconds inside the river and have constantly gone like this with how much speed? 5. So 5 into 50, which will be 250 meters. 250 meters. My drift will be 250 meters. I hope this is something which you are understanding. I hope this is clear. Is this clear? Yes, I will give everything, guys, in the Telegram group. Don't worry, I'll give everything in the Telegram group. Now, one last thing. What if I want to reach point B? What will I do, guys? What if I want to reach point B? What will you do? If you want to reach exactly point B, think about it. What will you do? You'll have to steer your boat somewhere here so that you end up reaching here. You'll have to, yes, correct. So you'll have to adjust. You'll have to adjust so that you reach here, correct. Let's say my boat velocity is more. Okay, if my boat velocity is more, then I don't have to steer so much toward that side because I can use a small component of the boat velocity and cross the river in the shortest path. So this is crossing the river in the shortest path. Yes. Now imagine a case when the boat velocity is something like 10 and let's say the river velocity is, okay, or boat velocity is little bit less, like 7 or something, and river velocity is more. River is moving really fast. What will happen? No matter what you do, you will never be able to reach the other point. No matter what you do. Look at that. Why? Because you'll never be able to cancel river's velocity. River is moving faster than you. How will you be able to cancel? I hope this is clear. So you can never cancel it. So you will have to have some drift. You cannot have no drift. I hope this is very clear. Amazing. I'll be sending the link on the Telegram group. Okay, so we have seen all the cases, guys. I hope you enjoyed this. Now let's solve some problems so that you get a bit of hang of this, how to solve and how to actually formulate the equation. So let's go swimming. Are you guys ready for swimming? Are you guys up? I know it's Saturday, but I hope you guys are up for more 10 minutes. Yes? Yeah, Devash, that's why I'm going to tell you how to solve problems, right? Don't worry. A river of width 100 meters is flowing from west to east at a speed of 5 meters per minute. A man on one bank wants to swim at 20 meters per minute. Find the shortest time he takes to cross the river and what is the drift. Okay? So two questions are there, guys. You have to find the drift and the time, right? So let's do both of this. Okay, so let me draw the river first. These are the banks. The width of the river is 100 meters. So that is 100 meters. And Let's say he starts from this point A and west to east, let's say is that side. River speed is 5 meters per minute. So understand this one over here is W and man's speed is 20. So this is U. Resultant, I don't know. Find the shortest time. Shortest time means how should he swim? I just told you. He should swim exactly perpendicular. So this is U. Okay. Where is W? It will be here. That is where W is. I hope this is clear. Very good. Some of you already found out the answer. Amazing. So he will end up swimming in this direction. So this is V vector and he will end up reaching somewhere over here. This is where he reaches. This is the point directly opposite point A. So this much distance is the drift. So what is the time taken to cross? Remember, time taken to cross does not depend on river velocity. I just told you now. So forget the river. Time taken to cross. You just have to think, oh, there are two lines. I am going like this. How much time will I take to cross from this line to this line? Okay. My velocity is always already perpendicular because I want to go by shortest time. So if shortest time, remember, theta is 90 degrees already over here. This is 90 degrees. Okay. So that's it. Time taken to cross is distance between banks upon the velocity perpendicular to the banks. That's all you need to remember. Don't by heart any stupid formula which are given in various books. Please throw them apart, tear the pages. It's not needed. So what is the distance between the banks? 100. And what is the velocity perpendicular to the banks? Okay. That is 20 meters per minute. That's good. So this will be nothing but how much? 5 minutes. So that's the answer, guys. He spends 5 minutes inside the river. That's what the answer is. Okay. And I want to find a drift. How do I find the drift? So that drift which he encounters, X, will be, think about it, he was in the water. So the time spent in the water multiplied by the velocity in the x-axis or towards right side. What is the time he spent? 5 minutes. What is the velocity in that direction? Well, he's swimming this way, so that swimmer's velocity has no role to play. Only the river water has some role to play. He is moving at a speed of 5 meters per minute. And please understand, this was also in minutes. So that minute cancels and this will become 25 meters. I hope this is clear. Very good. Amazing. So many of you have got the answer before. See guys, you have understood it. That's what I can see. I can already see that. Very good. Okay. So that was the answer, 5 minutes. And next answer was 25 meters. We got that. Okay. This problem is done. Now let's do the last problem for today. Are you guys ready? Let's sail through rough seas. Very rough seas. Let's sail through it. So this we already did. You cannot cross a river to the exactly opposite point if the speed of water is less than your speed. If you are moving with lesser speed than the river speed, you, no matter what you do, you cannot reach the opposite point. You will try to swim against it, but your speed is less. You are going to move back. You're going to move back. So your speed should be higher than the river velocity. Understand that. Okay, so that was done already. Very good, true. Let's solve this problem. 400 meter wide river flowing at this rate. Boat is sailing at 8 kilometers per hour with respect to the water. Find the angle with respect to the river at which the boat should point and sail so that there is no drift. Okay, let's do this. Let's see what and all we know. Okay, this is the width of the river, D given. 6 kilometers per hour is the river speed, so W given. And boat is sailing with the speed of 8 kilometers per hour, that is U, which is given. And find the angle at which, okay, so I have to find theta with respect to which the river should flow so that he should point and sail such that there is no drift. Very important, no drift. X is equal to 0. Okay, so let's draw the diagram first. Remember, that was the last part of the simulation which I showed you. So this is where he starts. This is the opposite point. he should be able to reach here. So his final velocity will be here, and that is only possible if he points or steers the boat this way such that the river velocity and his own velocity's effect eventually will be here. So that is how he should sail. Okay, so this is 90 degrees. This is the diagram. Yeah. Now, yeah, quite a high speed. And the river velocity is smaller than the boat's velocity. That is good. So that means he can reach the opposite point, or else the answer will be not possible. So that's one good thing. Now let's start substituting values. Okay, so first of all, what is this theta? Think about it. Let's use opposite by hypotenuse. So let's use sine theta. So what is sine theta? W by U. What is W? Just check it out. That was 6. What is U? Well, that was 8, right? Just check this out. Yes, that's fine. Is that correct? Is that correct, guys, everyone? Is it 37? Is it? Is it? I don't think so. Yeah, it is not. So just leave it like that. I mean, at max we can do is 3 by 4, guys. 3 by 4. That's it. Yeah. So basically, theta will be sine inverse of 3 by 4. Understand? That's it. Sine inverse of 3 by 4. It's not 37. Because for a 37 degree triangle, this should be 3, this should be 4, this should be 5. The hypotenuse should have been 10 then. It won't work. Yes, sine inverse of 3 by 4. Yes, that's the answer. Correct. Very good. So there will be no drift in this case. Amazing, right? Amazing, right? See, we found out the angle at which you should steer the boat so that you do not encounter any drift. Yeah, it's not 37. A lot of people write 37. Yeah. Yes, Chini, you'll be getting the extracts within a day, because one topic is remaining, that is integration, which I'm going to do on I think Tuesday. And after Tuesday, when 1D is complete, then you're going to get the extracts. So don't worry, okay? Don't worry. Yes, because I left that integration for a particular reason, because that's the hardest part of 1D. So I've kept the hardest for the, or the best for the last. So, okay. So that was today's lecture, guys. What an amazing session we had. And next time when we are going to meet, we are going to discuss integration. Remember, this lecture is for integration. And this is next week's timetable. Take a screenshot. Integration, Newton's laws, all about Newton's laws, first, second, third, FBDs, tension, this, that and all. Pulley, multiple pulleys, strings, tension, etc. Non-inertial, that is pseudo force, frictional force, static, kinetic, and different conceptual problems on frictional force, everything on Newton's laws. So it's all dynamics next week. Complete lecture devoted for dynamics. Yes, guys. And understand, I have kept the pace of the lectures suitable for not just live, but also even when you see it in recorded form, you will always understand it. And I have also kept in mind that whatever I do, I'll do it properly, because that's a promise I made you. All right. So that is the session plan for next week. And do not worry, by November end, I'm going to do most of 11th important portion, which will help you sail through, yes, the 11th standard portion very easily. And by the way, those of you are wondering which is the Telegram group, this is the one. Please join it right now to get the extracts, which is the complete summary, point-wise, formulas, definitions, diagrams, everything. You will get it here, including the session assignments. Please remember the drills for this session, what I conducted today, will be displayed on Monday, not tomorrow. Monday. Okay. Yes, Sudhir will do advanced problems as well. I want to do a combined session of kinematics and dynamics, because just kinematics is not that fruitful. When you combine both the chapters, you get beautiful problems. Yeah. So remember, that's going to be always the case. So Monday to Saturday, you will have sessions. The session of Saturday, which will be conducted, those drills will be posted on Monday morning. So you just have 1 day gap. Okay, 1 day gap. And that's how it is. Okay. Great, great. So do not forget to subscribe if you're a new user. Do not forget to like if you enjoyed this video. And do not forget to share if you want to spread the joy, of course. Did you guys love it? Did you guys love it? Amazing, amazing. Chalo, bye-bye guys. Have a happy weekend. Happy Dashera. Happy Navratri. Have a great time with your family. Happy whatever festival you are celebrating, just be happy, stay happy, enjoy these lectures, keep coming, get your friends also along. Let's make this family bigger. We have already reached 5,000 subscribers. Amazing. That's too good. Happy Dashera, guys. Yes, bye-bye. Take care, guys. Yes, I keep reading all your comments, so do not forget to post all your comments and I'll also reply to them. Bye-bye. Take care. Take care. Have fun. Have fun. Have a great weekend. Bye-bye. Signing off.